Hi, my name is Anshu and welcome to my channel Bottleneck. This is a data structures and algorithms series. In this series, we will be implementing algorithms and data structures using Scala functional programming approach. All the code related to our video can be found in the description as a link to my GitHub repository. This video is part 3 for TimSort. If you haven't seen the part 2 and part 1, I will provide the link of the part 1 and part 2 in the description. So in part 1 we had seen how and what is TimSort and how we can implement. In part 1 we started implementing the first part of the TimSort, that is the merge sort, and in this part we are going ahead and finishing our TimSort itself. So let's begin. Dev TimSort. Let's create a method for TimSort and give it the parameter. Say we have an input value which will be of type sequence. Again, v doesn't has any comparison. Let's give it an implicit extending order trait to add comparison, and let's return the sequence itself after sorting is done. So now we are going to implement merge. This merge is same what we implemented for merge sort, so it will have left and right, and it is going to and it is going to return a sequence of type V. Now as we know that this is going to return a sequence of type V, so it will be doing same thing what we did in the merge sort. The only difference is the run line, but that we will be taking care in the logic itself. So let's implement this. Now we will be using fold left. Dot fold left. Here we are going to pass the first value is our merged, second is left and third is your right, and then we implement the logic itself. So now so the first is the merged, second is left remaining, third is right remaining equals to triple. So now this is, let's correct this spelling here. Now we do a pattern match on left remaining and right remaining, left remaining comma right remaining. Okay, so now we have first case. So what would be the first case? If I have nil in left and right as the value, so what we are going to expect here, if there is no value in the left, so we are going to simply merge it. So it is going to return merged comma nil comma r tail, and it will repeat until the entire right is empty. Second is case I have left tail and right is empty, there is no value, it's nil. So it will do same thing, left merged comma L tail comma nil. Now okay, so here sequence of V, why it is okay. This is wrong. It should be like this. Alright, so next condition, if I have values both ways. So now as we remember, we have a value both ways, so we will be comparing head of each of the element, and accordingly the logic will proceed. So the next case would be case I have L tail, comma, R tail. Now if, so what we are going to check is left, the value of left tail is greater than right. If so, then we are going to merge, and we are going to pass the L tail, comma, R tail. Okay. Now if that is not the case, if we have same values, like if we have same value but the head of left is less than, instead of less than it is greater than or equal to the right, so it will do reverse of it, merged, comma, L tail, comma, R tail. So now this completes our merge method. Okay, so now merge is done. Next thing is we have to return, so this has to reverse because we are appending at the beginning. Similarly, you can change the logic the way you like it. Okay, here this is missing. Alright, so now we had this merge perfectly done. Now next thing is implementing the logic for tim sort. So if input dot length is less than equal to minimum run, then we are going to implement insertion sort on the input, else we are going to split left, comma, right as input dot split at input dot length divided by 2 in the equal half, and we will have left sorted. So this will happen recursively till we reach the minimum length. The array size is equal to minimum run length, so it will call tim sort and it will be left. Similarly, val right sorted is equal to tim sort with right. Alright, now we are going to call merge on top of it. So let's call the merge left sorted, comma, right sorted. Okay, so now we are done with our tim sort. Let's test this tim sort. So we already have this sequence here. Let's cut it and paste it here, change it to tim sort. Now let's run it and see whether we are getting the expected result out of it. Yes, it is working perfectly fine as expected. This is the expected output: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12. This is what we are expecting out of it. So points to remember: we have something called minimum run length. It is going to compare every element, the length of the every element or the array. It should be less than equal to minimum run length. If so, then it will run the insertion sort. If not, then it is going to further divide. It will divide and divide till it reaches this condition, and then it will be sorted. And once the sorting is done, it will start merging back. So this is how tim sort is implemented. So this is one way to represent what happens in the tim sort. Now If you enjoyed this video, please like and subscribe. We will see more and interesting algorithms going ahead. So please press on bell icon to catch on future updates. Thank you.